Hi, welcome. Today's lesson is on chemical reactions, predicting products and predicting if a reaction occurs. So for next lab, we're going to do some double replacement reactions. There's actually many different types of reactions. When I burned the flash paper at the beginning of the semester, that was a combustion reaction, but these are going to be double replacement reactions. And what is a double replacement reactions? It's when you mix an ionic compound that you dissolved in water with another ionic compound that you dissolved in water, and you form two more ionic compounds. And what happens is they switch partners. You can think of an ionic compound as a pair of a cation and an anion. So here I have an ionic compound. We'll call this cation A and anion B. And if I mix that with another ionic compound, which is also a cation and an anion, it's called a double replacement reaction. And replacement means that they swap partners. So this cation then goes with this anion. So the green one goes with the yellow one. And then note, we always say the cation first. So it's not the blue one with the red one, it's the red one with the blue one. So I have an ionic compound, which is a cation anion, AB, reacting with another ionic compound, which is a cation and an anion, CD here. They swap partners, and A goes with D, and then C goes with B. So let's put some actual ionic compound names in there. So let's say cation A is sodium, and anion B is carbonate, and cation C is magnesium, and anion D is nitrate. So I have sodium carbonate reacting with magnesium nitrate. So now they're going to swap partners. The sodium now is going to go with the other anion. So it's going to go to the nitrate, and the magnesium is going to the carbonate. And remember, you always say the cation first. So we get this. Sodium carbonate reacting with magnesium nitrate. They swap partners, and it becomes sodium nitrate and magnesium carbonate. And we can also write those like we did in the last lab with the chemical formulas. So Na2CO3, because it was +1 -2, so this is the formula. Magnesium is +2 and nitrate is -1, so this is the formula. Sodium nitrate is +1 -1, so this is the formula. And magnesium carbonate is +2 -2, so this is the formula. And you may notice that even though we write the equations, even though there was 2 sodiums as a subscript here, there's not a subscript here too, and that's okay because this was +1 and -2, so we needed the subscript, but this is +1 -1, so I don't need the subscript. So what happens when there's 2 sodiums on this side and only 1 sodium on this side? We have to balance the equation. So pause the video and see if you can balance the equation, and then come right back. Did you get it right? 2 sodiums over here, so I need a 2 sodiums over here. 1 magnesium, 2 nitrates. There are 2 nitrates because the 2 goes with not just the sodium, but also with the nitrates. So it is a balanced equation. So we should be able to predict the products. Remember, the positive goes with the other negative. So it's positive, negative, positive, negative. So the sodium now goes with the carbonate, and the potassium, say the positive one first. You don't say sodium carbonate and chloride potassium. It's sodium carbonate plus potassium chloride. There we have it. Let's give another example. So what happens if I mix potassium phosphate with calcium nitrate? They swap partners. Potassium now goes with the nitrate, and calcium now goes with the phosphate. So there you have it, potassium nitrate plus calcium phosphate. So pause the video and see if you can figure out the products from the next reaction, aluminum nitrate plus ammonium hydroxide. Pause the video and see if you get that. Did you get that right? Aluminum now goes with the hydroxide, and ammonium goes with the nitrate, and put the positive or the cations first. Great. But just because we write them doesn't mean they actually occur. So now we have to figure out what reactions actually happen, because sometimes if you mix something together, nothing happens. If I mix salt water With sugar water, I get a solution that's a salty, sugary mix, but no reaction actually took place. It's just a mixture. So just because you mix things, you can have a mixture of compounds or a mixture of elements or a mixture of elements and compounds or a mixture of ions, but you have to have something new to have a chemical reaction. So in the lab we can see if a chemical reaction takes place. So these are some of the things we can look for to see if a chemical reaction takes place. So make sure you write this down in your notes. You can look for an unexpected color change. So if you mix blue paint with red paint and you get purple paint, that is not a chemical reaction. That is just mixing two things together. You didn't really make a new product. An unexpected color change would be in the lab if you mixed a blue solution with a red solution and you got a green solution. That would be an unexpected color change. Or if it went clear, that would be an unexpected color change. Temperature change. Sometimes things get hot, like if you burn something, that gets hot. Sometimes things actually get colder. That's a temperature change. Sometimes when you mix things together, maybe you mixed in your kitchen some vinegar with baking soda and you get this bubbling volcano, that shows you a gas is formed. You get a gas form. Sometimes you get light. You get a light coming out of the reaction, and that tells you something's taken place. But the last one is the one we're going to be concentrating on, is a precipitate forming. That means something new that wasn't there before was made. And in the lab, we're going to mix two aqueous solutions together and look to see if they become cloudy or if you can see little solid chunks. Most of the time, it just looks cloudy. And that tells you that little solid pieces were formed, which is called a precipitate. So we're going to look for this one. Did you get something cloudy? Which means a solid was formed and you have something brand new and a chemical reaction took place. So how do we going to tell for a double replacement reaction if a reaction actually took place, if we're not in the lab? You can tell if a reaction takes place when you mix two ionic compounds that are already dissolved in water. If both of the products are soluble in water, they're both aqueous, no reaction occurs. So if you mix sugar water and salt water together, everything is still soluble. Nothing has happened. It's just a mixture. No new chemicals were formed. Everything is still separated and dissolved in water. But if you mix two ionic compounds that were dissolved in water and you get a solid, or one of the products is insoluble in water, so look at the products. If one of them or both is insoluble in water, then a precipitate has formed. So how can I tell if I'm not in a lab if a reaction will take place? Well, we have something handy called a solubility chart. And that tells you if things are soluble or not soluble in water. So we know these terms. AQ means aqueous, which means it's soluble in water. Solid means it is not soluble in water, and that would form as a precipitate. We just have, I think, one or two D's here. D's mean it actually decomposes and breaks apart. So that would be a different type of chemical reaction that we're not going through. So to find out if something is soluble, like aluminum acetate, so that's this first box here, you find aluminum here, acetate here, and it says AQ, so that would be soluble in water. If you wanted to know aluminum with bromide, that is also soluble in water. Aluminum and hydroxide, however, is not soluble in water. So, was a precipitate formed? In the lab, you can visually see that. But we can also predict it from our solubility chart. So let's go back and look at these three equations that we did at the beginning and see if a chemical reaction actually takes place. One of these two products, or both, but just at least one of these two products has to be a solid. And there's usually not a case where they'll both be solids, but one of these two, if they're solids, a reaction took place. If they're both aqueous or they're both soluble in water, then everything in the beginning was separated and floating in water, separated and dissolved in water, and at the end everything is still separated and dissolved water. You just made a mixture. You did not have a chemical reaction. So let's go look at these products with our ion chart, our solubility of ion chart. So sodium carbonate and potassium chloride. What are they on the solubility chart? So we have sodium carbonate. So here is sodium and here is carbonate, and we see where these two intersect, and we have aqueous. And you may note, to save yourself some time, notice all the sodiums here, they're all aqueous. So all of the sodium ionic compounds are aqueous. So that one's aqueous. What about the second one, potassium chloride? So I'm going to find potassium, which remember is K, and then I go over to chloride, and it is also aqueous. And if you notice for potassium also, aqueous all the way across. So this is aqueous and this is aqueous. What does that mean? That means I just have a mixture. I do not have a chemical reaction. There is no reaction. There is no new sodium carbonate. There is no new potassium chloride. Everything is still just floating around separate in water. So now let's look at the next reaction. And the products are potassium nitrate and calcium phosphate. So are either of these a solid? Well, once again, let's check our list on solubility. Potassium nitrate. Well, if you remember, potassium was soluble with everything, but here is potassium and nitrate. It is aqueous. And what about the other one, calcium phosphate? So we look up calcium here and phosphate all the way over here, and that's where the two intersect. Calcium phosphate is a solid. So we did make a new compound, and that is calcium phosphate. And we had now two solutions that were aqueous, and we produced a solid. A chemical reaction has taken place. So what about the last one? So pause the video and look at the ion chart. It's on your blackboard, and see if aluminum hydroxide and ammonium nitrate are soluble or aqueous. Soluble, which means aqueous, or if either of these are a solid. So we'll take a break and come back. Did you get it right? Aluminum hydroxide was a solid. Let's double check. Aluminum and hydroxide is a solid, but ammonium nitrate is not. Ammonium is right here in the second, and nitrate is here, and that's aqueous. So hopefully you got them right. We're going to have a lot more practice in the lab. So see you then. Thanks for listening.